to another lesson. Today's learning goal is I can identify proportional and non-proportional relationships from a table, graph, and equation, and I can identify the constant proportionality from a table, graph, and equation. Well, we've already done this with a table and an equation, because remember that equations always come in the form of y equals kx. If it doesn't come in that form, then it is not a proportional equation. And we also learned how to identify the constant of proportionality from a table and from an equation, because in an equation it is always the k. And then from a graph, or excuse me, a table, it's going to be, we have to find the x and the y, and k equals y over x. Okay. So here it says the distance Leia travels every hour on her bike is given in the table below. What is the independent variable x? So we got hours and miles. Remember that time is almost always going to be our x, what we can control. We can control how long we are riding our bike. And therefore the dependent variable is going to be the miles that she bikes. At 0 miles, she has traveled at 0, well, let's just say at 0 hours, excuse me, at 0 hours, she has traveled 0 miles. Why does this make sense? Okay. Well, it makes sense because, if it will let me, if Leia hasn't started to travel, then that means she couldn't go anywhere. Thus, we would have gone 0 miles. Now, notice how when we try to find the constant of proportionality here for this situation, we can do, this is our x, this is our y over x, k equals y over x. Remember, that is very important. So we're going to do 6 divided by 1, which is 6, 12 divided by 2, which is 6, 18 divided by 3, which is 6, 24 divided by 4, which is 6. Now notice how we can't do that with 0 and 0. Okay? Even though our equation for this would be y equals kx, which is y equals 6x now. 0 and 0 makes sense because if I plug in 0 right here, then 0 would come out because 6 times 0 is 0. But we can't use this to find our constant of proportionality. So therefore, even though we are going to get 0, 0 for each equation that we have that's a proportional relationship, we can't use it to find the constant of proportionality. Okay, so therefore we don't have to use this one. When x equals 0, we don't have to test it with this. Okay, we can't do 0 divided by 0 again. Remember that, because anything divided by 0 doesn't make sense. 0 divided by 0 does not make sense. We cannot divide by 0. Okay. So, to restate that, a proportional relationship will have a pair of x and y such that both are 0, since x times 0 equals 0. That is, this column will always be there. Even if it's not written inside the table, all proportional relationships will come out to have, if x equals 0, then y equals 0. Okay. Since the proportional relationship can have a pair of x and y such that x and y are both 0, we do not need to divide y by x to determine the relationship between x. Determine the relationship between x and y are proportional. Okay? That means that we don't have to use this to test to see if the unit rate is constant. So the proportional relationship is the relationship below between bikes sold and dollars made proportional. So here we're going to determine if this is proportional, and again we're going to skip this column. This column does not matter for determining if it is proportional or not. Okay. So what we're going to do is 120 divided by 1, 240 divided by 2, 360 divided by 3, and 480 divided by 4. And what we decide is that each of these bikes is worth $120 per bike. Okay. Again, the constant of proportionality is the ratio between the two quantities, in other words, y over x, or the unit rate. In the example of Leia traveling on her bike was the constant of proportionality. We determined that that constant of proportionality is 6 miles per hour. 6